Welcome back to day 10 of the Topic Blast revision series, and for today's walkthrough, the topic we're looking at is solving equations and inequalities. Hopefully you've had a chance to work through those questions, and let's go through the answers together. So our first question is solving a simple linear equation, one of our standard equations that we'll see quite often when we do questions, or if we do a more complex one, it kind of ends up in a position like this. So in this question, what we want to look at is, will that equal sign? What I like to do is put a line down through that, and that separates the left and right hand side for me. And I know that whatever I do to the left, I must do to the right. Similar to fractions, whatever I do to the numerator, I do to the denominator. When I'm solving an equation, whatever I do on the left, I do on the right. Now, solve, all that means is to find the value of x. So we want to figure out what that x is, or in some cases it might be y or z or w. We want to figure out that unknown, that letter, that variable. So to get that, we're going to try and isolate that. So the first thing we're going to do is we're going to get rid of this 5. We're going to subtract 5 from both sides. That gives us 3x equals 6. So we know what 3x is. To then get 1x, we're just going to divide both sides by 3. And that gives us x equals 2. So our answer to this is x equals 2. Now the way that we can check this, and you can do this mentally if you wish, but the way you can check this is we just take that 2 and substitute it back in. 3 times 2 plus 5 equals 11. Well, 3 times 2 is 6 plus 5, and 6 plus 5 does give us 11, so we know that we're correct. Second question looks quite similar to the first one. The only difference is this fraction. What we're going to do then is we're going to first get rid of this 4 on the bottom. Now again, remember, we put our line down through our equals. This over 4 as a fraction, that means divided by 4. So the inverse, or the opposite of that, is to multiply by 4. And remember, we have to do the same thing to both sides. Now multiplying the left by 4 just gets rid of the denominator and keeps the numerator the same. 2x minus 3 equals 7 times 4, which is 28. And now we're back to an equation that looks exactly the same as one we had before. We're going to add 3 to both sides. We get 2x equals 31. And then to finish off, we're going to divide both sides by 2. Now, 2 doesn't go into 31. But what we can do is we can either leave our answer as 31 over 2, which I often recommend you do as an improper fraction, or if you want to, you can write that as a decimal, which is 15.5. But if you're not comfortable with that fraction to decimal conversion quickly, I recommend you just leave your answer like this as an improper fraction. Now our next question is a slight variation again on a very, very similar skill. In this case, we've got 4x over 7 take away 6. Now, what's really important about being able to read that and say that 4x divided by 7 minus 6 tells you the order to do this in. Because the last thing I said was take away 6, the first thing I'm going to do is I'm going to get rid of that take away 6 by adding 6 to both sides. Then I get 4x over 7 equals 8. Now I'm back to a very similar situation like I had last time. I have a fraction, so the first thing I'm going to do is get rid of that denominator by multiplying both sides by 7. That gives me 4x, because remember my numerator stays unchanged, and then 8 sevens are 56. Finally then, to just finish this off, we divide both sides by 4, and we get x equals, now 56 over 4, we can simplify that because they're both even, but let's just check if it goes in. If you can't do that in your head, just a little bus stop on the side. 4 into 5 goes once, remainder 1. 4 into 16 goes 4 times with no remainder. So 56 divided by 4 is 14. And what we have to be conscious of with this is that if we are in a situation and we leave it as an improper fraction, but it does have a whole number answer, you will lose a mark on that. So if it simplifies down to an integer, you must simplify it down. Again, taking this one step further, looks similar, but there is a slight difference here. And the difference in this question is we've got 2 x's. So we've got 2 terms containing an x. And what we're going to do is we're going to get rid of one of those first. Okay, and that's going to bring us back to a situation like we've had before. Now, I like to get rid of the smaller x. So in this case, this is my smaller x, which is 2. The reason I like to get rid of my smaller x is because what that allows me to do is remain working with positive numbers. So it stops the unnecessary use of negative numbers. So the opposite of plus 2x is subtract 2x. And we're going to do the same thing over here. Now look where I line this up. I line my 2x up under my 13x. because they're like terms, so I'm going to collect those together. 13x take away 2x is 11x. I've done nothing to the minus 4, so that's going to stay as negative 4, equals 2x subtract 2x is 0, so I can cancel those essentially, and then my 7 remains where it was. And now I'm back to what we had in our first question. We've got an x, a constant, and then another constant. So getting rid of the negative 4, we add 4 to both sides. We get 11x equals 11, and then we just divide both sides by 11. 11 divided by 11 is 1. So in this case, x equals 1. And again, just a reminder how we check this, we can sub that back in. 13 times 1 minus 4 is equal to 2 times 1 plus 7. Well, that's 13 take away 4. And this is 2 plus 7. 13 take away 4 is 9. 2 plus 7 is 9. 9 on both sides, so we know that we're correct. So again, it works checking if you've got an unknown on both sides as well. It's a good habit to get into to check your answers back. Now this question looks like a simple one, but is often one that students make a mistake on and they lose a mark. This actually tends to be worth 2 marks. It says x squared equals 81. Well, all we have to do is figure out, well, what's the opposite of squared? And you probably already know it's a square root. So x is equal to the square root of 81. So the square root of 81, most people say it's 9, finished, move on. That's not entirely correct. The correct answer is actually plus or minus 9. Why is that? Because 9 times 9 gives me 81, and minus 9 times minus 9 also gives me 81. Now the only time we actually have to consider this plus or minus in this situation is when we're solving an equation. If we were just given a question that said, for example, the square root of 49, we would just say, well, the answer is 7. But because it's x squared equals 81, because it's asking us what number can we square to give us 81, we have to consider both answers. So therefore the correct answer is plus or minus 9. Now this one again is slightly different. We've got our unknown on the bottom. So these last two have just been kind of some unusual ones that you may come across. So this unknown on the bottom, all we have to do in this situation is if we've got this, we're just going to take the two of those and we're going to swap them around with each other. Okay, so we end up with 27 over 9 is equal to x, and then 27 divided by 9 gives me 3. So x equals 3, or if you want, you can leave your answer as 3 equals x. It means exactly the same thing. So x equals 3. So if that unknown is on the bottom, just swap it with the other side, and then that's a nice way to quickly rearrange it. So the second half of this video is about the inequalities section and solving linear inequalities. We solve these in exactly the same way as equations. The only difference is when we get to the end, we have to make sure that we keep that inequality sign. So this inequality sign here, we're going to treat as if it's our equals. We're going to put our line down through it. And we're going to solve this in the same way we just did. Plus 5, plus 5. So that gives us 6x is less than or equal to 18. Dividing both sides by 6, we get x is less than or equal to 3. Now if we were asked just to solve it, we must write x is less than or equal to 3 on our answer line. If we just write 3, it's not correct. We have to include the inequality sign. Now it asks us to plot our solution on a number line. Usually you'll be given a number line drawn, but if you have to sketch one, what I'd like to do is I draw my number line. In the middle of that number line, I put the value that I started with, so that 3 that I need to start with, that's the value I've got as my answer. And then I just add a couple each side. So 4 and 5, 2 and 1. Now, so it starts on 3, so we're going to put a circle above that 3. And then it's less than or equal to. So because of that line underneath, that means we're going to colour this circle in. So if there's a line underneath, we colour in the circle. If there's no line underneath, then we leave the circle blank. And then we have to decide, well, this is less than, so it goes to the left. So these are the numbers that are all less than or equal to 3, and it continues on. Now, the nice little trick that I like to look at is if you look at this top part of the symbol, it looks like your arrowhead, and it tells you which way your arrow is going to point. So you can use that as a quick way to check that for you. So you can see in this case, my inequality sign looks like it's the end of an arrow pointing to the left, so my arrow points to the left. Now this one looks slightly different because we've got an equation but there's an answer on both sides. Sorry, we have an inequality and there's an answer on both sides. So in this case, we have to treat this the same way we did before, but we treat it as if there's 3 sides. And I say that I use that loosely, 3 sides. So think of it as I said, 3 sides. Okay, but what we do to the center, we must do to the left and to the right. So in this case, we're trying to get this x on its own. So if we subtract 2 from the middle, we do it on the left and we do it on the right. So therefore that's -6 is less than or equal to 3x, which is left in the middle, which is less than 9. And then to get x on its own, we divide the middle by 3. So we divide the 9 by 3 and we divide the -6 by 3. And that gives us -2 is less than or equal to x is less than 3. Now, if we were asked to solve this or simplify it, that's enough. But it asks us to list all the integer solutions. Now that word integer, remember, means whole number. So we want to find all the whole numbers that are between -2 and 3. So in this case, we can use -2, -1, 0, 1, and 2. Because of this inequality symbol, that means not equal to. So it's not equal to 3. So therefore we go up as far as 2, and it only asks for integers, which are whole numbers. This one has, with the line underneath, means equal. Well, it means less than or equal. Okay, less or equal, and this is less or equal, and this is less and not equal. So therefore it includes the -2, but does not include the 3. Similar question here to what we had a moment ago, but it combines our first and our second question in our inequalities. So we're going to do exactly the same thing. We're going to treat it like it's got, as I said, as I use that term, 3 sides. We're going to add our 11 to each of the sections. So that gives us 9 is less than 3x is less than or equal to 18. And then dividing everything by 3 gives us 3x less than or equal to 6. Now in this case, it asks us to plot our solution on a number line. So we're going to draw a number line. As I said, usually you're given one of these, and we need the numbers 3 and 6 to be on there. So I like to start have a little bit wider than that. So let's go 2, 3, 4, 5, 6, 7. If we want, we can go 8. Okay, so we're above our 6 and we're above our 3. And because there's 2 ends to it, we don't have to worry about where the arrows are. These two things just join to each other because it gives us a start and an end. We know x is between those. Again, the only thing we have to remember is because of this sign, it's got an equals underneath. So we're going to colour in that 6. And that would be our solution on the number line. Because it's less than or equal to, we include the number line. But with the 3, there's no equal part. So therefore the circle remains empty. Now this one looks very simple, and it is, but there's one little trick here that we have to remember. The key here is that when we divide or multiply by a negative, we must reverse the inequality. Now what does that mean? Well, in this case, to get x on its own, we have to divide both sides by 2x. Sorry, by 2. So we divide them both by -2. That makes this side x and makes the other side -4. But because we've divided by a negative, our sign changes from less than to greater than. So the key here to remember is if you divide or multiply by a negative, we must reverse the inequality. So our answer here is that x is greater than -4. So the next two questions are slightly different. We're looking at quadratic inequalities. Now in an earlier video we looked at quadratics, and obviously in this video we looked at inequalities, so it's trying to bring those two things together. You may not have seen a quadratic inequality before, but this is a good opportunity to have a look at how they work and how you can combine these two skills together. So the first thing we're going to do is we're going to solve this quadratic, and as we said in an earlier video, the easiest way to do that is to factorize it. So I need two numbers that multiply to make -7, and add to make 6. So that's going to be plus 7 and minus 1. Now to solve this, we solve this by letting each bracket equal 0, and then that gives us x equals negative 7, and on the other side gives us x equals 1. Now the easiest way to do a quadratic inequality is to draw a quick graph. So if we draw a graph of a quadratic, remember, we can just draw an axis, just a quick sketch, and it's going to be this U shape. The important points are the two numbers we just figured out is minus 7 is one of the roots and 1 is one of the roots. Don't worry if your graph's not too accurate. We're using this for a very simple purpose. The purpose is that we're going to look at this inequality. We want our quadratic to be less than 0. To be less than 0 means it needs to be underneath the graph. So we're looking just at this section here. So therefore we know the values that satisfy this inequality are between minus 7 and 1. And we know it's not an inclusive, it doesn't have the equals on there. So we're looking at this very simple one, and we end up with minus 7 is less than x is less than 1. In the next example, we'll look at what happens if the sign was the other way around. Now for our final question, we're looking at this quadratic inequality. As you can see, as I said a moment ago, the sign has been reversed. There's a little bit of work we have to do as well before we get started, but we can do that easily. Now remember, anytime we need to solve a quadratic, it must equal 0. Same thing is true for an inequality. So we're going to get rid of that 11 and bring it over to the left hand side by subtracting 11 on both sides. So we've got minus 11 here and minus 11 here. That gives you plus 6 is greater than or equal to 0. Now we're going to factorize this quadratic. We've got our two brackets. We've got 2x in each of them. And remember, we're looking at this 2 times 6, which is 12. Looking at our factors of 12 that add to make 7, well, 1 times 12, 2 times 6, 3 times 4. 3 and 4 multiply to make 12 and add to make 6. So we've got plus 3 and plus 4. And remember from our earlier video, we have to divide this one by 2 to give us 2x plus 3 and x plus 2. Again, like we did before, we're going to solve both sides in this. So just to quickly do that, x is equal to minus 3 over 2 and x equals negative 2. As we said in the last one, the best way to do this is with a sketch. So let's sketch this quadratic. We want to be a bit accurate, so both of our roots are on the left hand side of the y-axis, so it should look something like this. Okay, again, doesn't have to be too accurate, it's just a sketch to help us work it out. So this is minus 2, and then this is minus 3 over 2. Remember, 3 over 2 is 1.5, so it's bigger, so it's going to be closer to 0. Now in this case, it asks us to make it greater than or equal to 11. So because it's greater than, or you can see down here we made it greater than or equal to 0, it means it needs to be above the line. So it's represented by this section and this section. Now as we know, they continue to get further and further either side. So what we end up in this case is we know that, and it's actually going to be a split inequality. First of all, we know that x is going to be less than or equal to negative 2. That represents this side. And then the other side, x is going to be greater than or equal to minus 3 over 2, which represents this time. And then because it's, the reason it's equal to is because our inequality here was equal to. That brings us to the end of today's video. As always, thank you so much for watching. I hope you found this helpful and the explanations were useful, and we'll see you in the next video.